Hello, Math 141. A vertical asymptote is a vertical line corresponding to a value that specifically makes the denominator only equals zero. And let's just look at like a few examples. Suppose I have f of x equal, say, 1 over x minus 2. We know that it at x equals positive 2, the denominator is not defined. But at x equals to 2, nothing is happening to the numerator. So I do have a vertical asymptote. So at x equals 2, we do have vertical asymptote. How do I show that on the graph? So let's say this is x and this is y. At x equal positive 2, we show that by a dotted line. And our graph of this rational function will never ever touch the line y, this dotted line, my vertical asymptote. Uh, okay, let's do another one. Suppose I have f of x say x over x to the second minus 25. Okay, is there any vertical asymptote? Well, let's see. I can rewrite this. If I factor the denominator, I have x over x plus 5, x minus 5. So I can see that at x equals negative 5 and x equals positive 5, the denominator is 0, but not the numerator. So I have vertical asymptotes at negative 5 and 5. So if I were to show the graph of this rational function if I were to show the asymptotes at positive 2, 3, 4, 5, and 1, 2, 3, 4, 5, these are the vertical asymptotes for f of x. Let's do one more. Suppose I have some g of x equal x plus 2 over x to the second, say plus 7x plus 10. Okay. So notice that in the first glance, we are looking at this and we are going to say that g of x is the same as x plus 2 over x plus 2, x plus 5. And now I do have a dilemma in here. I know that algebraically I can cancel this. And so g of x, I can rewrite it as 1 over x plus 5. So you look at this and you go like, okay, I know at negative 5, I do have a vertical asymptote. So at x equals negative 5, we have vertical asymptote. Vertical asymptote. But how about x equals negative 2? It is true that if I look at here, negative 2 is not doing anything. So I don't have a vertical asymptote in, like, if I look at here. But if I look at the original problem, at x equals negative 2, g of x is not defined. So what do I do? Well, here's the things. If you have a value, like in this case, negative 2, that makes the numerator and the denominator 0, then you do not have a vertical asymptote. All you have is a very tiny, teeny hole in the graph. So at, let me give myself a little bit room here. So at x equals -2, we have a hole in the graph. And the hole is such a tiny, just only at that value, so tiny, teeny that it's impossible for you to see it with calculators or even with big screen. Anyways, but when we do these problems on the paper, we show at -2, we are supposed to show a small hole in the on the graph of this rational function. Okay, I'll do another video with slant asymptotes, and we can put everything together soon.